Stop scrolling. Are you ready to truly master one of the biggest topics in high school science and general knowledge? We're talking about our solar system, and here is the jaw-dropping fact that explains everything. Our Sun holds 99.8% of the total mass in this entire system. All the planets, moons, asteroids, and everything else. That's the remaining tiny fraction. This is the Solar System Masterclass from Chapter 10. Whether you're in Class 9, 10, 11, or 12, or just preparing for a competitive exam, we're breaking down the complex structure, formation, and physics of our cosmic home into simple, easy-to-understand concepts. Let's make sure you ace this chapter. Our story starts about 4.6 billion years ago. The solar system wasn't always here. It began as a massive cloud of gas, dust, and ice called the Solar Nebula. Due to some trigger, like a nearby supernova, this cloud began a process called gravitational collapse. As the cloud pulled inwards, it started to spin faster and flatten into a disk. All the matter rushed to the center, creating immense pressure and heat. Eventually, the temperature hit millions of degrees, igniting nuclear fusion. This ignition marked the birth of our Sun. The Sun is essentially a giant fusion reactor, turning hydrogen into helium and releasing the enormous amount of energy, the light and heat, that sustains our entire system. Remember, the Sun is the system's gravitational anchor. Without it, everything flies apart. We divide the solar system into two main neighborhoods. First, the inner solar system, home to the 4 terrestrial planets. Terrestrial just means Earth-like. They are small, dense, and made mostly of rock and metal. Mercury is the smallest. It has almost no atmosphere, making its days scorching hot and its nights freezing cold. Next is Venus, the hottest planet. Not because it's second closest, but because its incredibly thick atmosphere traps heat, a runaway greenhouse effect. Its pressure would crush you instantly. Then there's Earth, unique for its liquid water and its atmosphere. Crucially, Earth has a strong magnetic field, which protects us from harmful solar radiation. This is a vital difference from our neighbors. Finally, Mars, the famous red planet. It's covered in iron oxide dust, giving it that rusty color. High school students note this. Mars is much smaller than Earth, and its gravity was too weak to hold onto a thick atmosphere over billions of years, which is why it's a dry, cold desert now. Separating the rocky worlds from the gaseous worlds is the asteroid belt. This is not a solid wall, but a huge torus-shaped region full of irregularly shaped metallic and rocky bodies called asteroids. The dwarf planet Ceres lives here too. Now we enter the outer solar system, home to the Jovian planets, or the gas giants. They are colossal, have low density, and are mostly composed of light elements like hydrogen and helium. Jupiter is the undisputed king. It is so huge you could fit all the other planets inside it. Its gravity is vital, often sweeping up debris and protecting the inner system. Remember its defining feature: the Great Red Spot, an atmospheric storm that has raged for centuries. Next is Saturn, famous for its complex and stunning system of icy rings. The rings are not solid. They are composed of countless pieces of rock and ice, held together by gravity. Saturn also has the huge moon Titan, which has its own dense atmosphere. Beyond that, we find the ice giants, Uranus and Neptune. They contain more heavier elements like water, methane, and ammonia. Uranus is unique because it is tilted almost 90 degrees on its side. Neptune, the farthest planet, is famous for having the fastest, most violent winds recorded in the entire solar system. The journey doesn't end at Neptune. We enter the icy frontier. This massive ring is called the Kuiper belt. It's much larger than the asteroid belt and is packed with thousands of icy bodies. This is where we find dwarf planets like Pluto and Eris. For high school students, remember the official definition of a planet requires it to clear its orbital neighborhood. Dwarf planets haven't done this. They share their orbit with other objects in the Kuiper belt. And finally, the theoretical boundary, the Oort Cloud. This is a massive spherical cloud of icy objects extending halfway to the next star system. These objects are thought to be the source of long-period comets, those that take thousands of years to return. The Oort Cloud truly marks the farthest boundary of the Sun's gravitational influence. Now let's get into the high-level physics that keeps this entire system running. Everything is governed by two principles: inertia and gravity. Gravity is the Sun's massive pulling force, constantly trying to drag the planets straight inwards. But the planets have inertia, their tendency to keep moving in a straight line at a constant speed. The balance between the straight-line pull of inertia and the inward pull of gravity locks the planets into their predictable elliptical orbits. This stable motion is mathematically defined by Kepler's laws of planetary motion. The first law tells us orbits are elliptical, not perfect circles. The second law says planets move faster when they are closer to the Sun and slower when they are farther away. But the most fascinating is the third law, which shows the relationship between a planet's distance and its time period. The farther a planet is from the Sun, the longer its year is, and the slower its average orbital speed is. This is a direct result of Newton's law of universal gravitation, which says the gravitational force decreases by the square of the distance, the inverse square law. This means Neptune feels far, far less pull than Earth does. Understanding this simple balance of forces is the key takeaway for high school physics. It explains everything from why Jupiter doesn't crash into the Sun to why comets take thousands of years to complete one orbit. Our solar system is truly a clockwork mechanism run by fundamental physics. We've covered the structure, the formation, the difference between the rocky and gaseous giants, and the incredible physics that governs every moment of motion. You now have a complete, master-level understanding of the solar system. If this masterclass helped you conquer this chapter and feel ready for your exams, smash that like button. Don't forget to subscribe to Chapter in 10 for more high school science explained simply. Be sure to also check out our dedicated playlist, The Universe Files, for more videos on galaxies, solar systems, and everything in between. Thanks for watching and keep looking up.